Welcome back to the deep dive. Today, we're diving into something really fascinating from C.R. Morris. It's this idea called Nullons as the zero of space-time.
Mhm.
And it really makes you stop and think, what is empty space? The idea is that the void, what looks like nothing between things, isn't really empty.
Right. It suggests it's actually dynamic, maybe even countable, a participant in the universe.
It's a mind-bending idea,
Yeah,
honestly.
it really is. And, well, our goal today is to explore how these nullons might just, completely change physics by quantizing absence, giving nothingness properties.
Okay.
Think about the number zero in math. That's the core analogy Morris uses. Zero made nothing measurable, right? It gave it structure.
Yeah, absolutely. I mean, before zero, math was way simpler, almost just counting things.
Exactly. Bookkeeping, basically.
But zero gave us positional notation, negative numbers, algebra. It stopped math from just being, well, basic arithmetic.
It unlocked complexity.
Mm-hmm.
And Morris is saying, what if nullons do that for physics? He calls them the quantum placeholder of void.
Quantum placeholder.
Yeah, like the smallest possible unit of pure emptiness in spacetime. He terms them bosonic quanta of the void field.
So, like, photons are for light, these nullons are for emptiness.
Precisely. It makes nothing countable. It
Yeah.
turns the vacuum from just this passive background
Into something active, a field.
into a dynamic field, yeah. Which, physicists have struggled with the problem of nothing for ages. Quantum foam, vacuum energy,
Right, the cosmological constant problem, 0-point energy predicting infinite energy.
exactly those things. Nullons offer a potentially, well, elegant way to think about these deep puzzles.
Okay, so if nothing gets a job description, what does this quantized void actually, do? How does it help with those big problems?
Well, that's where it gets really interesting. Morris suggests they measure and modulate expanse.
Yeah.
They basically define a minimum discrete distance unit in the vacuum,
A smallest possible distance.
kind of like a pixel size for space itself. And this isn't just abstract. It connects to Einstein's cosmological constant.
Ah, the mysterious dark energy component.
Right. Instead of a fixed constant, Nullons frame it as these quantized, maybe even time-varying placeholders, and that runaway zero-point energy from quantum field theory.
The infinite one.
Yeah. Nullons reinterpret it. It's not an infinite sum, but discrete contributions from these nullons. It could be a way to unify these ideas, maybe bridge quantum mechanics and general relativity by making this problem of vacuum energy into a feature of quantized absence.
Wow, okay. That's a big claim for nothing. So does this mean emptiness actively participates in how the universe behaves, like these non-interaction zones you mentioned?
Yes, exactly. Emptiness isn't passive in this view. It actively mediates where things don't interact or how they interact across voids. The void influences dynamics.
Okay, and then there's this other layer you hinted at. Nullons are just one thing. There's a hierarchy.
You got it. It gets even more structured. Morris proposes different forms of void quanta.
Different types of nothingness. Sort of, yeah.
Yeah.
Based on their properties, like spin. First, you have scalar nullons, spin 0. Think of them as point-like absence. The basic unit, no direction.
Okay, a dot of void.
Then, vector nullons. Spin 1. These have directionality, like oriented gaps or line-like placeholders, an empty line segment, if you will.
Directional nothing. Okay.
And 2-form nullons, rank 2. These represent area absence, like void tiles or dynamic patches of emptiness.
This is like a surface of nothing.
You could think of it that way, yeah.
Huh.
And finally, 3-form nullons, rank 3. These deal with volume absence, filling up 3D regions of space-time as, well, void volumes.
So points, lines, areas, and volumes of pure emptiness are
Yeah.
all countable units.
That's pretty radical.
I bet there's some pushback on this.
Oh, absolutely. It's a huge philosophical pivot, as Morris puts it. Physics usually quantizes presence matter, energy fields.
Right.
Quantizing absence is, well, it's bold. But the key thing is, it's not just philosophy. It potentially leads to testable predictions.
Like how could we even test for structured nothing? Well, if nullons are modulating space, they could subtly change the history of cosmic expansion or affect how large structures like galaxy clusters grow over time.
Ah, so tiny differences in the large-scale universe.
Exactly. Things that big surveys like DSI or Euclid are actually designed to measure with incredible precision. They're looking for subtle deviations from our standard models.
So finding those deviations could be evidence for nullons.
It's a possibility. It would certainly make people look much harder at this framework. It offers a potential explanation for anomalies they might find.
This whole deep dive really forces you to rethink what empty space even means. It challenges that basic assumption that it's just nothing.
It absolutely does. If emptiness is structured, if it has this hierarchy, if it's quantized, then maybe nothing isn't just the absence of things.
Maybe it's fundamental.
Maybe it's one of the most profound participants in the universe, providing the very stage, the scaffolding for everything else. Really makes you wonder, doesn't it?
It does.
What new physics might be waiting for us if we finally start to understand the true zero of space-time?